So far, we have learned how to apply recursion to several of the topics we have previously covered in this course. Now we will learn how to utilize recursive algorithms to sort objects in a method called merge sort. Here we can see the implementation of a merge sort method used to sort an array of integers. The merge sort method splits the argument array into two halves, and as long as each half has more than one element, the merge sort method will be called with each half array as an argument. Once each subsequent half has reached the size of 1, the merge method is called to combine all of the individual arrays. Here is the implementation for the merge method. We can see that the comparison between the two argument arrays begins with the first element of each. If the current element of the first array is less than the current argument of the second array, then the value from the first element of the first array will be assigned to the next empty element of an output array. If the opposite is true, then the first element of the second array will be assigned to the output array. As soon as one of the argument arrays becomes empty, all of the elements of the other array are placed in order at the end of the output array. The importance of the merge sorting method comes from its consistency. The previous sorting methods that we have studied, including insertion sorting and selection sorting, all have the problem that their efficiency varies greatly depending on the initial state and size of the argument. The number of comparisons required to sort an argument using previous methods can vary from just over half of the size of the argument all the way up to the size of the argument squared. Using merge sorting presents a more reliable and often more efficient way to sort objects, because a merge sort method will always use the same number of comparisons for arguments of the same size. That number being the size of the argument multiplied by the logarithm of the size. Let's apply this reasoning to a real example. Let's say we have an array with 10,000 elements, all assigned completely randomly. Let us also assume that we have a device limited to performing the maximum of 1 million comparisons per second. If we choose to use a selection sort or insertion sort method, there is a possibility that we would have to perform up to 100 million comparisons. Therefore, the sorting process could take up to 100 seconds. If we choose instead to use merge sorting, the number of comparisons will always be 40,000, and that the sorting process would take nearly for 1,000th of a second. So, you may be asking, is there ever an appropriate time to use either a selection sort or insertion sort method? And the answer is yes. Whenever you are in a situation where you have a group of items that are already close to being fully sorted, it becomes appropriate to utilize these options. This is due to their ability to ignore sometimes massive portions of the collection being sorted. Merge sort, as stated before, number of comparisons, so even if only one item is misplaced, merge sort will still compare everything. So, to conclude, recursive properties prove to be very useful and efficient in sorting processes. The merge sort method establishes a stable and consistent benchmark that other sorting methods fail to match. Barring several special circumstances,